Hi everyone, my name is Francesca Lazzari and I'm a cloud advocate at Microsoft. In this video series, we are going to learn together how you can get started with machine learning on Azure. Here is an overview of what we will be covering. As you can see, we will start by answering probably the most important question, that is, what is machine learning and how you can select the right machine learning algorithm for your data science scenario. Then we will see how Azure Machine Learning tools can accelerate your machine learning journey. Then we will do an exercise about building a machine learning model with Azure Machine Learning Designer. This is going to be followed by another exercise about deploying and consuming a machine learning model with Azure Machine Learning Designer. After that, we will try to understand together how you can use automated machine learning to optimize your machine learning deployment flow. And finally, we will see how you can deploy your machine learning model on Azure through a real exercise. Let's start by answering this first, a very important question. What is machine learning and how you can select the right machine learning algorithm for your data science scenario? In order to understand better what's machine learning, it's also important to understand what's the difference between deep learning, machine learning, and AI. So let's start with deep learning. Deep learning is a subset of machine learning based on artificial neural networks that permit a machine to train itself. In this case, the learning process is called deep because the structure of artificial neural networks consists of multiple input and output and hidden layers. Each layer contains units that transform the input data into information that the next layer can use to perform a certain predictive task. Thanks to this structure, a machine is able to learn through its own data processing. Machine learning is a subset of artificial intelligence that include techniques such as deep learning, and these techniques enable machines to improve a task with experience. In this case, the learning process is based on these following steps. First of all, you need to feed your algorithm with the data by providing it with more information, for example, by performing feature extraction. Then you use this data to train a model. And finally, you test and deploy the model, and you can consume the deployed model to perform a certain automated predictive task. Artificial intelligence is a technique that enables computers to mimic human intelligence, and it includes machine learning. And it is important to understand the difference between machine learning, deep learning, and AI. Machine learning is a way to achieve artificial intelligence, which means by the use of machine learning and deep learning techniques, you can build computer systems and applications that can perform tasks commonly associated with human intelligence, such as visual perception, speech recognition, decision making, but also translation between different languages. Probably many of you are more familiar with the traditional programming logic, so let's try to understand machine learning leveraging traditional programming logic. So this graphic shows the difference in how traditional programming is created versus a machine learning model. Traditional program is statically program logic to get an output. Static results are generated based on the program logic in the algorithm itself. In machine learning, on the other side, you have data, and this data is called features or variables. And then you have also an output, which are your labels. That goes through the algorithm computation, and then a model is created, which at basic level is just a mathematical function that is created with your data. And this is called training your model. As a next step, it is important to understand when you should use machine learning. Here are some common machine learning algorithms and the questions that they answer. As you can see, there are two main types of machine learning, supervised and unsupervised learning. We have regression and classification under supervised machine learning. Regression is great at answering questions how much or how many. Classification is great at answering question which class does this object belong to. The main types of unsupervised machine learning algorithms are clustering, anomaly detection, and recommendation. Clustering is about grouping things together to groups or partners in the data. Anomaly detection is about answering the question, is this weird? You may get emails from your credit card company pointing out weird transactions. Those are probably the results of an anomaly detection algorithm, and the transaction didn't fit your normal partners, your normal data and behavior. Recommendation: which option should I choose? Now that we understand better what are the different categories of machine learning, such as supervised learning versus unsupervised learning, let's try to understand how you can select the right algorithm for you. Understanding the predictive power of a set of features with respect to a dependent variable, which is your target variable, which is the variable that you want to predict, is a very tricky problem, and there is no universal metric which can tell you exactly what to do. So the answer to the question, which algorithms, is always it depends. It depends on the size, quality, and also the nature of your data. It depends on what you want to do with your answer. So I would suggest that you start with asking yourself, what do you want to do with your data? As you can see from this algorithm cheat sheet, here there are different answers, and based on different answers, there are different set of machine learning algorithms that you want or can use. For example, you want to predict between different categories. In this case, a multi-class classification probably is the best option for you, and under the multi-class classification family, you have different options. You can predict between the two categories. This is, again, it's more like classification. In terms of classification, there is also a specific set of algorithms for classification of images. Then the recommender systems, discover structure, find unusual occurrences. This is anomaly detection. If you want to predict a numerical variable, as you can see, you can use the predict value categories, and under that there is a regression family with a lot of different algorithms that you can pick to build your machine learning models. Finally, text analytics. This is about extracting information from text. Also here in this family, you have a lot of different options. So always start with asking yourself the question, what do I want to do with my data? Finally, let's talk about the model building process, which is a very, very important structure that every data scientist follows in order to build end-to-end machine learning solutions. Here, as you can see, there are 4 main steps. There is prepare data, train your model, test your model, and then deploy your model. First step is about preparing data. We need to find, select, and create the data, apply pre-processing techniques, and feature engineering. Then we need to train the model. Once you have your prepared and clean data, now it's time to test different machine learning models to see which gets the best results for your data and for your data science scenarios. This is a very iterative process, because you may need to change the data or the model or different parameters until you think that you have a very good candidate for your model to be deployed. After train model, you have a test model. So now you have a model that you think is going to perform well and that you can test with different data. This is, again, it's a very iterative process, because eventually you want to go back and try different models. And the best way to do this is to split your data set into training and test data set. And so the test model is the moment in which you are going to use your testing data set in order to see how your trained model is performing with the new data. The final step is about deploy your model. So once you have the chosen one, the right model for you, the best candidate for your data science scenario, it's time to operationalize it, meaning that you're going to create a web service on top of it, so that you're going to give other scientists or other students or other people in your company or outside your company the possibility to consume your model. Here are some of the resources that you can look at if you want to learn more about Azure Machine Learning. There is a repo with a lot of documents. You can find it at aka.ms/azuremldoc. If you want to learn more about the difference between deep learning versus machine learning, you can look at aka.ms/deep learning versus machine learning. If you want to learn more, what are the different algorithms that you can pick based on your data and your data science scenario, look at the document aka.ms/algorithm cheat sheet. And finally, there is a nice document about how you can select different typologies of algorithms, and you can find it at aka.ms/select algos.